Jai Hind, dear students. I am Dr. Supratim, Associate Professor Swami Vivekanand Subharati University, Meerut, and in today's e-lecture, we are going to discuss the introductory topic related to microwaves. Here, the topics that we are going to discuss in this lecture can be shown here. What is a microwave? Microwave systems, advantages, disadvantages and applications, microwave hazards, transmission line theory, types of transmission lines, advantages and disadvantages, waveguides, followed by conclusion. Now we are looking at a subject which requires a lot of theoretical knowledge, and as we progress in the e-lecture, we can expect little bit theory mixed with numericals and derivations as well. So what is a microwave? A microwave is nothing but a form of electromagnetic radiation with wavelengths shorter than other radio waves, but it also is longer than infrared waves. Its wavelength ranges from about 1 meter to 1 millimeter, corresponding to frequencies between 300 megahertz and 300 gigahertz. Now when we discuss about a microwave system, as you can see, there are various parameters that we can associate it with. A microwave system normally consists of a transmitter subsystem, including a microwave oscillator, waveguides and a transmitting antenna. Along with this, there is also a receiver subsystem that includes a receiving antenna, transmission line, waveguide, a microwave amplifier and a receiver. For an example, a reflex klystron gun diode, traveling wave tube, which we also know as TWT, and magnetron are used as microwave sources. Now isolators provide low attenuation for the forward direction and high attenuation for reverse direction to avoid reflected power. When we go ahead in the circuit diagrams, we will also see some explanations. An attenuator provides attenuation for the power which depends upon the microwave application. A design of microwave systems. Now as we can see that there are various parameters, and in order to design a microwave system and conduct a proper test on it, an adequate knowledge of the components involved are essential. Therefore, a first course on microwave should include 3 major areas of study, and these 3 major areas of study are namely microwave transmission lines, followed by microwave waveguides, and as we can see that in the design of the microwave systems, we also need microwave circuit elements, microwave source amplifier and detector. So moving forward, we can see here in this particular diagram that the transmitting horn antenna is there and a receiving horn antenna is also there. Microwave source and power supply, what they are in coordination with the isolator and with the help of variable attenuator, they deal with the frequency meter, and with the help of detector there is this certain loop that we are getting here, followed by the oscilloscope and the power meter. So this includes in the next segment where we can see what are the advantages and disadvantages of a microwave system. Now because of its very high frequency, microwave system can carry large quantities of information. High frequencies mean shorter wavelength, which require relatively small antennas. Now microwave signals are more easily propagated, and due to this the physical obstacles such as water and high mountains, they never pose a problem. That is, line of sight problem is not there. Fewer repeaters are necessary for its application and amplification. Minimum crosstalk exists between different voice channels. For an example, if a transmitter is there and a receiver is there, both of them will have different parameters, and in case there is crosstalk, it will be definitely posing some problem. Therefore, each station will be using the separate parameters and it increases bandwidth availability. Now talking about the disadvantages, we can say that there are some other portions where it is more difficult to analyze and design circuits at microwave frequencies. Measuring techniques are more difficult to perfect and implement at microwave frequencies. Another point that we can discuss is it is very difficult to implement conventional circuit components, for an example resistances, capacitors, inductors and so on at microwave frequencies. The transient time is more critical at microwave frequencies as well. It is often necessary to use specialized components for microwave frequencies. Apart from this, microwave frequencies propagate in a straight line, which limits their use to line of sight applications sometimes, but not always. Okay. Some of the applications that we can see are related to telecommunication and radio spectrum, safety, biomedical and industrial. So these two are of utmost importance in today's era, but we can overall consider many other things. For an example, the microwave frequency spectrum is used primarily for telecommunication purposes and telephone communications and radar. Many long distance telephone application systems are using microwave links for carrying telephone calls. Apart from this, the microwave becomes very popular too in case of radio spectrum for material analysis. In a microwave landing system, we use it to guide the aircraft to land safely at airports. So it is also working in the sector of safety, you can say. Special microwave equipment known as diathermy machines are used in medicine for heating body muscles and tissues without hurting the skin. So this is particularly an example of our biomedical instrumentation systems. Apart from this, if we see various parameters, microwave heating is also used in industry for a variety of heating and melting applications. For an example, if we consider only biomedical instrumentation and its application in this particular field, we can say that microwave can be used in the frequencies 100 MHz to 30 GHz for the various following biomedical purposes. For an example, diagnostic applications, tumor detection based on the differences in tissues that it hampers the electrical properties and gets influenced by the electrical properties is one of the applications. Regional hypothermia integrated with MRI, therapeutic applications based on local heating, prostate, hyperplasia, heart and other tissue ablation. For an example, angioplasty is also used. Apart from this, MRI and fMRI are some of the biomedical applications. Now we are left with industrial application. So what can we say about industrial applications? Industrial microwave applications are rapidly increasing day by day. Their potential is in certain areas. The food, the rubber and textile industries arise from a combination of advantages. For an example, if we are seeing that efficient energy conversion, automation and product quality control, many other heating and drying applications are under consideration today. These also include pharmaceutical dyeing, film drying and veneer processing. Second and third generation of these equipments are now very successful in the industry. These applications range from various drying processes and oyster processing to the rapid heating of institutional lunches. Microwave proofing of bread products, for example, has been shown to require a lot of efficiency and it requires as little as fifth of the energy needed with conventional heating method. So here we are also looking at something, a technology which saves a lot of power as well. So only applications and advantages and disadvantages are not what we should be learning in this introductory phase of microwave systems. Microwave hazards can produce thermal and non-thermal effects in biological systems. The heating of tissue due to absorption of microwave occurs due to the ionic conduction and vibration to dipole molecules of water and proteins present in the body. So what happens is, here the rise of temperature plays an important role, and due to this we are having some hazards associated with microwave system. When the thermoregulatory capability of the body or parts of the body is exceeded, at that time we can experience tissue damage, which may be lot of problems, and it will also create lot of issues. Death usually results from the diffusion of heat from the irritated portion of the body to the rest of the body by the vascular system. So this is about the basic part of the microwave systems. In the following part, we are going to discuss about various microwave systems that we are going to study in detail after this. After this topic, let us understand the basics of transmission line theory. Now, we can see in case of transmission line theory is that it has two basic parameters: free space and transmission lines, that is connecting wires. An electrical signal containing the information can be transmitted from one point to the system to the another point by a certain distance through different media like free space. Now the propagation is from a source, that is radio transmitter, to a load, that is radio receiver, where wave propagation is carried out through free space. The separation between the source and the load could be very large. Here, that is, the separation can be very large and it can also be different. For an example, in case of very large, it can be thousands of icons as in cellular communication, or small, that is a very few kilometers as in case of microwave communications within a city. This type of wave propagation is called unguided wave propagation. Now in case of transmission lines, connecting wires, in some applications the information has to be conveyed from one point to the other through connecting wires. That is, telephone lines from different areas can be used and vice versa. For example, connection between a radio transmitter, as you can see, this is the overview of a transmission line. A connection between a radio transmitter can be used in order to explain the working of transmission lines. The type of propagation is called guided wave propagation because the electromagnetic wave is guided between the wires. These wires are actually called the transmission lines. The waves are guided between boundaries of the transmission lines. Thus, a transmission line is a conductive method of guiding electrical energy from one place to other. It is employed not only to transmit energy, but it is also used for propagating various information with the help of microwave systems. Capacitors, resonant circuits, filters, transformers, and even insulators at very high frequencies can be used. The nature of transmission line and its performance depends upon two factors: the amount of power to be transmitted and the frequencies involved. Hence, the transmission lines are categorized as power lines, which are used for transmission of large quantities of power over a fixed frequency communication line, and used for transmission of small quantities of power over a band of frequencies. Now, as we can see in this particular diagram, there are strip lines and two wire open lines along with coaxial cable. So here you can see there are width and there are various parameters that go into designing the transmission lines and how they will work. So what are the types of transmission lines? An open wire line, it is also called as parallel wire type. These lines are parallel conductors and parallel conductors open to air and hence called open to air lines. The conductors are separated by nothing but air, and as a result of this they are rigidly supported by cross arms put at a certain height from ground by means of galvanized iron poles or any other structure. For an example, telephone lines, electrical power transmission lines, electrical energy propagation getting through these lines are set up. They are set up with the help of electric fields between line conductors. These are at right angles to each other and to the direction of propagation, which is the length of the line. This type of energy transmission is known as the TEM, that is transverse electromagnetic mode of propagation. There has been some advantages and disadvantages. To name a few, less capacitance compared to underground cables are required here. Some disadvantages that we may include are initial cost is high due to the requirement of telephone posts and towers. On the other hand, possibility of shorting due to flying objects like birds, etc. can also pose to be a problem. Following this, we also have coaxial types. Now what happens in case of coaxial types? The radiation loss in an open to air line is made negligible by employing a circular cylindrical conductor of smaller diameter placed coaxially inside another hollow conductor. You can see in this particular image that what we are discussing about. Here the resulting structure is coaxial line. Here the inner tube is separated and insulated from the outer conductor by a medium which may be solid or gaseous. The two conductors are at two different potentials. The fields entirely confined to the space between the two conductors, and similarly no external radiation can penetrate the outer tube and propagate inside. Here the source is connected to the inner conductor of the coaxial line. At the other end a load named as ZL is connected. Now this particular load is connected to the conductor. The other end of the source, load, and the outer conductor of the coaxial lines are all connected to ground. They are all connected to ground. Therefore, coaxial is an unbalanced line, and here the wave propagation inside the coaxial is known as TEM mode. The electromagnetic wave is guided between the two tubes, and the outer conductor acts as a sheet to prevent what? To prevent leakage of signal from inside to the outside and vice versa. So coaxial cables are of three types. Flexible coaxial cable, they use copper braided outer conductor and center conductor and a low loss solid or foam polyethylene dielectric. Number two is semi-rigid cables. Here they are having solid dielectric and they use thin outer conductor so that it could be bent for convenience while laying cables. The third one is rigid cables. They have solid dielectric made of Teflon. The space inside the tube is essentially air with Teflon separating plugs at regular intervals. The coaxial cable can be used up to 3 GHz and therefore transmitting large signal powers. Beyond this frequency, the transmission of electromagnetic wave and along the CX becomes difficult to do. It can occur that in the solid medium, it needs support for the conductors and its corresponding losses. And this is also associated with a phenomenon called skin effect. Now let us move forward and discuss the concept of waveguides. a transmission line consisting of a suitable shaped hollow conductor which may be filled with a dielectric material and used to guide the EM waves of UHF propagated along its length is called a waveguide. The walls of the waveguide are made of brass, copper or aluminium. During the propagation, the waves suffer multiple reflections at the walls of the guide and the resulting distribution associated with the wave. This causes the transmission mode. And in the following process, what we can see is that since the electric and magnetic fields are confined to the space within the guides, there is no loss of power through radiation. Generally, the medium inside the waveguide is air. There is no loss of power due to dielectrics. However, there is some power loss in the walls of the waveguide, but the loss is very small. The loss in a waveguide will be less than in a coaxial cable. Inside a waveguide, several modes of electromagnetic waves can propagate. The TEM mode does not exist, but either transverse electric, that is TE, or transverse magnetic, that is TM modes can exist depending upon the mode of coupling the signal to the waveguide from the microwave source. If we look at this properly, the waveguides has some advantages and some disadvantages. One of the major advantages is higher power handling capability. A simpler mechanical structure is its benefit, which reduces the fabrication cost. Lower attenuation per unit length. Lower attenuation means stopping of the process. Attenuation means to prevent. Disadvantage: large cross-sectional dimensions and a lower usable bandwidth than in a coaxial cable. So these are some of the advantages and disadvantages of the waveguide that we are talking about. So at the end of this, we have come across this entire topic of introduction to microwaves, the process that involves various types of transmission lines, the applications, the advantages, the disadvantages, waveguides, its basic structure, and followed by its advantages and disadvantages. In the coming lectures, we will continue these topics and try to explore more into the subject of microwave theory. And I hope this has been informative to you, and thank you for watching. Jai Hind.